All right, so this is Study Guide A for Cumulative Parquet number 1. Here goes number 1. First things first, label anything that does not have an exponent with a 1. Distribute the exponent from outside the parentheses inside, so this becomes 2 to the third, q to the third, r to the 15th. This implies multiplication. Distribute, distribute. This is q to the 6th, r to the 6th. Are we there so far? Now that we multiplied, now we're going to simplify. This becomes 2 times 2 times 2, which is 8. These are the same bases. What happens to the exponents when we're multiplying? We add 3 plus 6, that's 9. Same basis are 15 plus 6, that's 21. Hands if you got that. Okay. That was number 1. Let's go to number 2. Distribute, distribute, that becomes m to the 6, m to the negative 6. This implies multiplication. Distribute, distribute, m to the negative 9, n to the 9. Are we there so far? Yeah. All right, next, let's simplify. M and m are the same base. What happens to the exponents when we multiply? We add, so that means negative 9 plus 6, that's negative 3. Same base, and what is 9 plus negative 6? That's 3. Are we done? No, we cannot leave this with negative exponents. The one with negative exponent goes to the denominator, and we change the exponent to a positive. This one stays on the numerator, and we're done. Hands if you got that. Okay. Once again, you're making note. If you got it wrong, write the correct answer tonight. You check where you made a mistake. Okay. Number 3. Simplify. A are the same base. 9 plus negative 2, that's 7. Bring down the b, or b to the first. Hands if you got that. All right. Looks like a superhero, huh? An exponential expression superhero. You guys don't see it? No? Number 4. Here we go. Once again, anything that does not have an exponent, what do you write? A 1. So here's a 1. When you draw the arrow, that's when you multiply. What is 4 times 1? 4. So you, I'm sorry. 4. So you write 2 to the 4th. 4 times 9, that's 36. So it's x to the 36 over. 4 times 4, that's x to the 16. 4 times 2, that's y to the 8. Simplify. This becomes 2 times 2 times 2 times 2, which is 16. Are these the same base? Yes. X. 36 minus 16, that's 20. Which is the only one we didn't use? Y to the 8th. It stays in the denominator. And we got that. Good. Number 5. Are we good so far? Number 5. Simplify. Let's see. What is 4 times 6? A to the 24th. What is 4 times 1? 4 divided by 2 is 2. So that's b to the 2nd. These are side by side, so it's multiplication. What happens with exponents and indexes? They divide. What is 9 divided by 9? B to the 1st. Are these the same bases? Yes. So therefore, I bring over the a to the 24th. And what is b to the 2nd times b to the 1st? That's b to the 3rd. And we got that. All right, good. Happy thing? Number 6. Okay, guys, these. Some of you, when you're going too fast, you see that this is about the same size as that, and you just multiply those. That is incorrect. You need to write exponents of 1 here and 1 there. Distribute. Negative 4 times 1, that's 2 to the negative 4. Negative 4 times 1, that's 4 to the negative 4. However, look at the numerator. Can we leave this as a negative exponent? No, so that one goes down here, and we change it to a positive exponent. But this one is in the denominator, and it's a negative. So what can we do to change it to a positive? We send it to the top, to the numerator. That becomes 4 to the positive 4 exponents. Therefore, get it? Therefore, 4. All right. This means 4 times 4 times 4 times 4. What is 4 times 4? 16. 16 times 16 is 256. This is 2 times 2 times 2 times 2, which is 16. What is 256 divided by 16? 16. Make a note. Good? All right, let's go to number 7. Simplify the expression. All right? First of all, we know that if we have an exponent that's a fractional exponent and the numerator is 1, we know we can make a radical right away. But this one has a 2, so that means we need to rewrite this one. So check this out. This one needs to be rewritten, so it becomes 64. The exponent, we make it into 1/3. But what happened to the 2? We need to write it next to it as times to the power of 2. Are we there so far? Now, why do we need it like this? Because now this can be written as a radical with an index of 3. What goes inside? 64. What was left outside? To the exponent of what? Everything to the exponent of 2. So what does this mean? This means that a number times itself 3 times, that gives us 64. What is that number? 4. Bring down the exponent of 2. What is 4 squared? 16. We're done with this one, so we do plus, and we go to the next one. This is square root of 25. What is square root of 25? 5. What is 16 plus 5? That's 21. Hands, have you got that? Okay, good. Do we need another one of these? We good? Experts? All right, good. Number 8. Is it coming back, all this? Yeah? Have you guys noticed that if they haven't left, we have this on each cumulative exam? Yay. Number 8. Okay, this one says simplify and write the answer in scientific notation. I want you to look up on this one. Check this out. First, I'm going to show you the common mistake. First of all, what do you guys see? 2 expressions with parentheses. What does your noodle want to do? It wants to multiply when they see parentheses. But one thing that you should notice that this is not multiplication, it's what? Division. So when you get to this, to save time and space, check this out. You see the division sign, so automatically underneath here you're going to draw a fraction bar. And then you write this one on the denominator. Does that make sense? So now we rewrote it from here. Now we rewrote it like this. So let's see. What is 4.6 divided by 2? 2.3. You guys notice? 0.23. Bring down the multiplication. Are these the same base? Yes. What happens to the exponents when we divide? Subtract. 11 minus 3, that is 8. Look at it. Is this scientific notation? Yes. And we're done. Now, what does scientific notation entail? That the number can only have 1 digit on the left of the decimal. How many digits? 1. And it cannot be 0. So it has to be 1 all the way through 9. And then it has to be multiplied times base 10 to an exponent. Okay? Hands, have you got that, by the way? Okay, good. Go to number 9. Oh, your favorite. Yay. There are 6.02 times 10 to the 23 atoms. And how many grams of hydrogen? 1 in 1 gram. But they want us to figure out how many atoms in 500 grams. So if this is 1, what do we need to do? Multiply times what? 500. But they want it in scientific notation. So I'm going to make this first in scientific notation. I put my invisible decimal and I move it twice to the left. If I move it twice to the left, then I write 10 to the 2nd power. Times what's left after where I move the decimal twice, we're left with just number 5. Are we there so far? This is scientific notation. Now we're going to multiply times this, 6.02 times 10 to the 23. So now since we have multiplication all the way through, I'm going to multiply numbers times numbers and bases times the same base. Therefore, 5 times 6.2 is 30.10. Are these the same base? Yes. So it's times 10. What happens to the exponents when we multiply? Add, so that becomes 25. All right. However, they want the answer in scientific notation. Look at it. Is this scientific notation? No, because we have 2 digits on the left side of the decimal. That means I need to move it how many times? Once. If I move it to the left, I need to add 1 here. When we move it to the left, we add. When we move it to the right, we subtract. Anybody remember that? Yes, Mr. Q. All right. This is 3.010 times 10 to the 26. We're almost done because look what they ask at the end. It says, round your answer to 2 decimal place. All right, so let's look at it. Here's the first decimal, and here's my second decimal. My second decimal is this one. Question, does this one stay a 1 or does it go up to a 2? Stays a 1 because this one needs to be at least a 5 or greater for this to go up. So this stays at 3.01 times. Now that we rounded, do we do anything to the exponent? No, it stays the same. Some of you in the last part you gave me this. What did you forget to write? Atoms in 500 grams of hydrogen. What is the atomic symbol? H. 10Q. You guys know your atomic symbols, yeah? Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluoride, neon. You know. I remember when I was in 7th grade, they made us learn 100 of them. Yeah, how many did they have you guys learn? No, we went home to play Fortnite. All right, let's go to number 10. Any questions on this one? Straightforward? All right. Oh, this one. My goodness. Simplify the expression. I'm going to go over this one, and I'm going to give you another one so you can practice this one. Pay attention, please. Here it goes. I'm going to do this by parts. I'm going to start with the number first. The number first is square root of 4. What is square root of 4? 2. I'm done with this one. What do I have left? C to the 5th, B to the 3rd. Now that we have variables only, look up. I'm going to write my invisible index. What is the invisible index? 2. Now, some of you still get confused when we go to the next step. You think you're taking the square root of this exponent. We're not. Julian, can you put that away? Thank you. So we're going to rewrite this because 5 cannot be divided by 2. Is that correct? Because if we divide it by 2, we end up with a fraction again. And if we end up with a fraction, it's going to be another radical like this. That means we need to rewrite this. How do we rewrite it? It has to be a multiple of 2. Is 5 a multiple of 2? No. What number before 5 is a multiple of 2? 4. So that means I'm going to rewrite this to c to the 4th. However, to make it c to the 5th, I need to multiply times c to the 1st. You guys see that? All right. So then put this in the radical with an index of 2. We no longer use this one. I'm going to focus here. Now, what is 4 divided by 2? C to the 2nd. I'm done with this one. Can I divide 1 by 2? No, I end up with a fraction again. So I'm going to leave it like that for right now. Look at this one. Is 3 a multiple of 2? No. What number before 3 is a multiple of 2? So I'm going to rewrite this to 2 to the 2nd times, b to the 2nd times d to the 1st. Are we there so far? Whoa. There it is. For the radical. We no longer use this one. So what is 2 divided by 2? B to the 1st. So I'm done with this one. So which are the only ones that we couldn't simplify? C to the 1st and B to the 1st. And those stay in a radical form. Both of them inside. C to the 1st, B to the 1st. Hands if you got that. Okay? I'm going to give you another one so you can do this one by yourself. I'm going to take off my scribble so you guys can see some of the work. All right. Example 10Q. Let's do a square root of 25 x to the 9th and y to the, give me a number, 11. 11. Go. See what you get. You're going to put that away. All right, here we go. So, who got 5x to the fourth, y to the fifth, square root of x to the first, y to the first? Okay, let's see how we got that. What is square root of 25? 5. This one is 9 a multiple of 2. No, what is a multiple of 2 before 9? So this is x to the 8th times x to the first. We no longer use this one, so what is 8 divided by 2? 4. That's how we get this. We no longer use this one. We're left with x to the first, which is right there. Is 11 a multiple of 2? No. What number before 11 is a multiple of 2? So that's y to the 10th times y to the first. Therefore, what is 10 divided by 2? 5, and we're left with y to the first. Let's do one more. See if you can go a little bit faster now. Example 10 super Q. Let's do square root of 49. M to the 15 and J to the 23. See what you get. All right, let's see what we got. Who got 7 M to the 7th, J to the 11th, square root of M to the first, J to the first? That is correct. Oh, 7-Eleven. Oh, like the store. All right, number 11. Okay, this one. If you get this one incorrect, I'm going to send Reagan to slap people around. My goodness. Here it goes. What degree is this one? Look at the exponent on the variable. What is it? 2. What degree is this one? There's no variable, so it's 0. What degree is this one? 4, because the exponent on the variable is 4. What degree is this one? 3, because the exponent on the variable is 3. Now we need to rewrite this starting with the highest degree, which is 4. So we write x to the 4th, then negative 2x to the 3rd, then plus 3x to the 2nd, and at the end, plus 14. That is standard form. Second part, we need it in leading coefficient. We look at the first term, look at the number that's multiplying the variable. What is the invisible number? 1. That's our leading coefficient. Next, we need a name for this polynomial. We start with the highest degree. What is the highest degree? 4. That means this is a quartic. All right. Next, we need a last name. How many terms? Is it 1 term? Monomial? No. 2 terms? Binomial? No. 3 terms? Trinomial? No. Anything after that is a polynomial. Yes? Do we need another one of those? I hope not. We did like a whole month of warm-ups on these. You remember? Like you would be waking in the morning, wake up to go to school. Oh, quintic polynomial. Right? No shake unit. Oh, quadratic trinomial. Number 12. Here we go. All right, this one, add or subtract. Here we go. I'm going to start with the first term. Circle it. Is there another p to the second? Yes. Yes, circle that one. Okay. So that means I'm going to combine these two. So I write p to the second. Does it say multiply? That's why we don't do anything to the exponents. We just write the same term. There it is. And we combine the coefficient. What is negative 3 and negative 16? That's negative 19. Let's go to the next one. P to the fifth. Is there another p to the fifth? Yes. So I write p to the fifth. I only combine the coefficients. What is negative 9 plus 12? Positive 3. At this point, are these the same kind of terms? No, even though they have the same variable, but look at the exponent. Is this the fifth? No, only this one, so we can't combine. Last thing to check, is it in standard form? No, that means I need to rewrite it. Is that correct? Which one goes first? 3p to the fifth, and at the end, negative 19p to the second. Make the change if you didn't do that, please. Number 13. Look at this one. Now this one, check this out. Common mistake that I saw last time. Look up. Some of you did this. Oh, 6b to the third times b to the third, 6b to the sixth. 6 times 8, that's positive 48b to the fourth. 6. No. What are you doing? What is that called? Multiplication. What is in big letters above that problem? So then why did you guys multiply? Don't multiply, my goodness. Add. What does that mean? We're going to combine like terms. The only thing you should check on these if there's a negative or a subtraction problem in front of the parentheses. Is there a subtraction problem here? How about here? No. No, so at this point we're going to combine like terms. I'm going to start with this one. Is there another d to the third? Yes, right here. So that means I write d to the third. I'm going to combine 6. What is the invisible number here? What is 6 plus 1? 7. Okay? Next, I go to the next one. D. Is there another D? Yes, so I write D. What is the invisible number right here? Negative 1 and positive 8. So what do I have left? Positive 7. Bring down the negative 1. Can I combine anything else? No, because this one has totally different exponent than that one. Is it in standard form? Yes. From highest to lowest degree. Hands if you got that. Okay. Number 14. Oh, yes. Let me zoom out really quick. Oh, people on this one. Here it goes. I'm going to start with the first term. What is y times y? Y to the second. What is y times negative 2? Negative 2y. What is negative 1 times y? Negative 1y. What is negative 1 times negative 2? Positive 2. Are we there so far? From there, we're going to combine like terms because we already finished multiplying. Bring this down. Y to the second. Negative 2y and negative 1y. That's negative 3y. And then I bring this down. Positive 2. Over there. Next, area model. Your favorite. Yay. Nice and straight like mine. So I'm going to write y minus 1. Y minus 2. Let's see. What is y times y? Y squared. What is y times negative 2? Negative 2y. What is negative 1 times y? Negative 1y. What is negative 1 times negative 2? Positive 2. And look what some of you did last time. Look up. Oh, that's that, Mr. Q. All right, minus 1. Did you combine like terms here? No, you just pointed to the other one. Wow. You already did the work. Finish it off. Let's see. What's here? Y squared. Draw your peanut. Can we combine these? Yes, negative 3y. This one, bring it down, plus 2. Then you box it and you're, oh, then you go, oh, I get the same as that. Well, guess what? Then you multiply correctly. Yes. Y. Where? Oh, switch these? Yeah. We good? Make sure you write your simplification for both. Let's do number 15. Very similar. Yes. I love these. Here we go. What is 3x times x to the third? 3x to the fourth. What is 3x times negative 5x? Negative 15x to the second. What is 3x times 2? Positive 6x. What is negative 2 times x to the third? Negative 2x to the third. What is negative 2 times negative 5x? Positive 10x. What is negative 2 times positive 2? That's negative 4. Let's combine. Is there another x to the fourth? No, bring it down. 3x to the fourth. What's the next degree below that? This one. Is there another x cubed? No. Negative 2x cubed. What's the degree that follows that one? Is there another x squared? No. Negative 15x squared. Next. Do we have another x? Yes. What is 10 plus 6? 16x. Bring down the negative 4. Is it in standard form? Yes. Nice. All right. Area model. 3x minus 2, line across. X cubed minus 5x plus 2. Line down, line down. Let's see. 3x times x cubed, 3x to the 4th. 3x minus times negative 5x, negative 15x squared. 3x times 2, that's positive 6x. Negative 2 times x cubed, negative 2x cubed. Negative 2 times negative 5, that's positive 10x. Negative 2 times 2, that's negative 4. Start from here, bring it down. 3x to the 4th. Bring this one down. Negative 2x, well, x cubed. Bring this one down. Negative 15x squared. Can I combine these? Yes, that's positive 16x. And bring this one down, negative 4. What did we notice? That we get the same thing as that. Piece of cake? Hands if you got that. Okay, good. Number 16. Common denominator, everyone. 30. By now you should be able to do these because we've been doing these on the warm-up, right? That is 30x plus 60 over 3 minus 30x over 5 equals 30x plus 60 over 10. Simplify. This becomes 10x plus 20 minus 6x equals 3x plus 6. Combine like terms. This one and this one become 4x plus 20 equals 3x plus 6. So far so good? Minus 3x minus 3x. We're left with x plus 20 equals 6. Last step. Minus 20 minus 20. X equals negative 14. Hands if you got that. But notice that I didn't ask to check or properties on these. Yeah, thank you, Mr. Q. Yeah, okay. Yeah. Good. Let's go to number 17. Line down the equal sign. Distribute 10x minus 6 plus 10 equals 7x minus 5. Combine like terms. 10x plus 4 equals 7x minus 5. Minus 7x minus 7x. 3x plus 4 equals negative 5. Minus 4 minus 4. 3x equals negative 9. Divide by 3. X equals negative 3. And have you got that? Okay, good. Number 18. Divide by 4, divide by 4. Absolute value x minus 6 equals 4. At this point, we write two equations. X minus 6 equals negative 4, and x minus 6 equals positive 4. Are we there so far? Let's solve. Plus 6 plus 6, x equals 2. Plus 6 plus 6, x equals 10. Am I done? No. Solution set 2, comma 10. Hands if you got that. Okay. Number 19. Minus 7 minus 7. Absolute value 6x minus 5 equals negative 1. Something's happening here because it's a negative. We can't have a negative because absolute values cannot be equal to negatives because absolute values are what? Are positives equal to negatives? No, that means no solution. Or error. Hands if you got that. Okay, good. And the last one from last night, number 20. Number 20. Your favorite. 3 consecutive integers. How many of them? 1, 2, 3. 1 across. That means 1 consecutive, 2 consecutive, 3 consecutives, and total. First, we need to set up the information given. 3 consecutive integers. Do we know the first one? No. X. What's the next consecutive? X plus 1. What's the next consecutive? X plus 2. This never changes. Now that we have that, I'm going to start after such that to write my equation. Let me zoom out. Hold on. Let's finish this. twice the greatest integer. Which of one of these is the greatest? X plus 2. If it's twice, that means 2 times x plus 2. I'll wait. Ready? Here goes. The word is equals. Look at the last part. From the last part, start with the last part of the last part. Let's see. 8 less than 3 times the least. What is the last part? 3 times the least. Which one of these is the least? X. If it says 3 times, what do we write? 3x. And then what's the first part of that last part? 8 less. So what do we write? Minus 8. Can we solve that? Yes. Distribute. 2x plus 4 equals 3x minus 8. Minus 2x minus 2x. 4 equals x minus 8 plus 8 plus 8. 12 equals x. Am I done? No. Substitute in here. 12. 12 plus 1. 12 plus 2. So that means this is 13. This is 14. Am I done? No. Statement. The 3 consecutive integers are 12, 13, and 14. And Q. Tonight's home play. Finish numbers 21 through 40 at home, and tomorrow we're going to cover those in class. There is tutoring if I don't see you. See you guys tomorrow. Bye. Enjoy your home play. Make it a math family night. Yay. Everybody gather around.